In this lesson, I will introduce you to inequalities. First, we're going to look at the differences between equations and equalities. Then we're going to talk about how to test solutions in inequalities. And then finally, we're going to graph inequalities on a number line. Before we go any further, I want to note that both equations and inequalities have the root word of equal. You'll notice that the prefix in actually means not equal. So on inequalities, it's things that are not equal. These are examples of equations. 2x plus 1 equals 9. And this is an example of inequalities. 2x plus 1 is less than 9. The solution to this one is x equals 4. The solution to this one is x is less than 4. Equations have a finite number of solutions. In other words, I can count how many solutions they have, unless it has infinitely many solutions, but that doesn't happen very often. This one has one solution. Inequalities, however, have an infinite number of solutions. There are infinitely number of things that are less than 4 that will make this inequality true. 3 makes this inequality true. 2 makes this inequality true. 0.5 makes this inequality true. So in inequality, it's really important that you don't just put 4, but you put that x is less than 4 so that the reader understands that you mean the solution is anything less than 4, not just 4. Let's talk about how we test solutions. Are these numbers solutions to x plus 2 is less than or equal to 2x? And for each one, we're going to say yes or no. So for 0, we're going to put in 0 plus 2 is less than or equal to 2 times 0. 0 plus 2 is 2. Is that less than or equal to 0? That is not less than or equal to 0. How about 1? The left side is 3. The right side is 2. That is not a solution. How about 2? Oops, I forgot to replace that with a 2. There's so many 2s. Okay, 4 is less than or equal to 4. Okay, because there's a line under here, the condition is it either has to be less than 4 or equal to 4. And 4 is equal to 4, so that is a solution. Now, on an equation, you might be tempted to just stop. But on an inequality, it could have multiple solutions, infinitely many solutions. So chances are good, actually, that this one is probably true as well because it's on the other side of that 2 that made it equal. 5 is less than or equal to 6. That is true because it is less than 6. So that would be a yes. Now we're going to talk about how to graph inequalities on a number line. Since inequalities have an infinite number of solutions, graphs are a great way to picture all of the possible solutions to an inequality. If you have the variable on the left, so if the x is on the left side like it is here, then the arrow points left of the graph that you're going to graph. It goes in the same direction as the inequality. If it's greater than, like in the middle here, where the inequality is pointing to the right, the arrow will go in the same direction that this is pointing, as long as the variable is on this side. It can't be on this side and have that rule be true. If it's less than or greater than, you put an open dot on the number, and if it's less than or equal to and greater than or equal to, you put a closed dot. So if it has this line under it, you put a closed dot on that number. Let's take a look at that in practice. We're going to graph x is less than 4. So it's not equal to 4, so we'll put an open circle on 4, and then the inequality is going to go this direction, so it's going to go to the left. Really shaky line there. Now, just a moment to note that even though it says x is less than 4, we still start on 4 with an open dot. Some students are tempted to start at 3 because it says it's less than 4 and not equal to 4, and they want to put a closed dot on 3 and start there. But If you do that, you leave out all the numbers between 3 and 4 that are also less than 4, like 3.9. The only way to include all of the numbers that are less than 4 is to actually start at 4, but put an open dot so that we know that 4 is not actually a solution, but everything less than that, including 3.5 and 3.2 and all of those, are also solutions. Now you remember I said the rules only work when the variable is on the left. So this one, the arrow is not going to go this way. It's actually going to go this way. And the easiest way to do that is to flip this all around so that you can follow those rules. So I'm going to start with y, and then I'm going to flip this to greater than, and then 5. So the alligator is eating the y, so when the y is on the other side, it should still be eating the y. This time it says y is greater than or equal to 5, so we're going to put a closed dot on 5 so we know 5 is included, and then it's greater than, so it's going to go to the right, same way that this is pointing now. And that's how you graph inequalities on a number line.